Good morning, friends. Today I will explain you vapor pressure. You see, vapor pressure depends upon the nature of the liquid and on the temperature. It means different liquids, they have the different vapor pressure. Now if we take a open container, suppose here we take the water as a liquid, then the evaporation starts and the water molecule they come out and spreads into the air. But when a water is taken in a closed container, what will happen? Suppose water volume is at a certain height and above this space is there, then evaporation of the water takes place and the molecules they are coming out from the water and they move in a confined space. When the water molecules they come out and confine in a space, we will see that the level of the water molecule decreases. Now when the concentration of the vapors increased in the space, they move randomly in all the directions and they collide with each other, and also the walls of the container and with the liquid surface also. We see there is a decrease in the level of the water. As the concentration of the water increases and it collides with itself, with the walls and the water level also, what will happen? When the vapor they come in contact with the water level itself, due to intermolecular attraction, the vapor they condense and goes to the water level. It means as the rate of the vaporization increases, then the condensation will also start. Again listen, when the vapors they go into the space, in a confined space, then the level of the water decreases. As the concentration of the vapors increases, it collides itself and to the walls of the container and also the liquid level. Now what will happen when the concentration is increases to so much that the water vapor when collide with the water level, due to the intermolecular attraction, it will condense and goes to the water. Now vapor formation and the condensation is started at one stage when the rate of the vapors and the rate of the condensation become equal. What will happen? When the rate of the vapor and the rate of the condensation becomes equal, we will see there is no further decrease in the height, that is the level of the water, and it becomes constant. It means that there is an equilibrium state reached between the vapor and the condensation. And so the level of the water becomes constant. So when the rate of the evaporation and the rate of the condensation become equal, This stage is known as the dynamic equilibrium. It means that two processes, that is evaporation and condensation, occurs at the equal rate. It doesn't mean that the process stops, but rate of the evaporation is become equal to the rate of the condensation. So at this stage, molecules of vapor exert the pressure with its liquid and in all the direction. This is known as the vapor pressure. So when a condition is reached, rate of the evaporation and the rate of the condensation become equal, and there is no, and we say that the level of the water become constant. This stage is known as the dynamic equilibrium state. It means here two processes, evaporation and the condensation, occurs at the equal rate, and at this stage pressure exerted by the vapors in all the direction and also on the liquid level, that is known as the vapor pressure. Okay, now this vapor pressure is defined as the pressure exerted by the vapor. The pressure exerted by the vapor in equilibrium state with its liquid at a given temperature, that is the vapor pressure. And this vapor pressure is a characteristic property of the liquid at a particular temperature, and it depends upon the nature of the liquid and the temperature. So this is all about the vapor pressure. It's very simple, it is clear to you. If you like my videos, please share and subscribe. Thanks very much.